तो पॉलिटिक्स के काउंटरक्लाम का रिकॉर्ड उनसे बेहतर है। अब हम ये बात करते हैं कि सॉफ्ट स्किल वर्सेस प्रैक्टिकल।
Hello guys, welcome to the video. Hello guys, welcome to the video. Yes, this is right. So let me share the screen here, entire screen. Or share system audio. Is this? No, we don't want to share system audio here. So audio source. Right. So welcome back guys to the, we will continue from the previous where we left there. Alright, welcome back. So next thing, in case of subgroup, we already know that order of the subgroup always divide order of the group, and operator in subgroup and the group is always same. So if order of group is even, then yes, this is also right. So we were saying that if order of the group is even, if order of group is even, order of G is even, then there exists a group. There exists an element A which has order 2. Element A which has order, the order of A is 2. This is the theorem, and number 1. Number 2 is if this is the another branch of this, you can say another branch of this theorem. If order of G is even, then there exist odd number of elements with odd number of elements with even order or order 2. Also we have done that size of, this is, we are talking about the group, okay, subgroup. So size of smallest non-trivial subgroup is 2. Alright. Next is, in every group of even order, we should do that. You know that, alright. So next is, every group of even order, then there is some element except identity element will inverse of itself. Then there is some subgroup order 2. So this is a very detailed theorem. What is it saying that for every group of even order, then there exists some element except E, the identity, except the identity element, there exists so this is related to this only, all right? This is related to this. So for every group even order, then there is just some element except E, which is will be inverse of itself. All right. What we can derive from this is that there exists subgroup of order 2. Subgroup of order 2. What we can say, like one is identity element and A. So for group inverse should exist. So identity is there, identity exists, but A is an element. Then inverse of this should be itself, because identity can never be. We can say identity. Identity can never be inverse of any element. Alright, inverse of any element. Except identity itself. Alright? Except identity itself. Alright, this is the thing. Then what we are discussing is every group of even order, then every group of even order. Alright. There's few things also there that say subgroup. One property is subgroup is closed under intersection. Subgroups are closed under intersection. For example, order of H and K is equal to is order of H into order of K upon order of H and K, like this, where H and K are subgroup of group G. Right? This is the thing. And what we are saying here is next thing is subset S. Let's say which is not equal to phi of G is a subgroup of the group G asterisk if it only for any of the element close to S. A asterisk D inverse also belongs to S. So what we are saying here is any subset S of G, S is not equal to phi. Right? S is a subgroup. Is subgroup of G if and only if any element A comma B for all A comma B belongs to S, then A asterisk B inverse also belongs to S. Like this. This is a condition. Right. So, next thing, guys, is half adder. So the one more important thing which can be asked in the exam is half adder. What is the equation of half adder and what is the things are? So half adder like this. Half adder for sum we have equations A XOR B, and for carry we have equations. What are the carry equations, guys? Only in case of one, alright? So AB. In case of AB, this is the carry equation. Alright. In case of full adder, guys, in case of full adder, sum will be A XOR B XOR C, and carry will be AB plus BC or CA. any two of any of them can generate carry. Okay. Next thing we will go for half subtractor. Equation of half subtractor. Half subtractor we can say subtraction equation same as addition A XOR B, but for we can say borrow equation when 0 1, all right, 1 0 not 0 0 not, so 0 1 A bar B is the equation for borrow. And for full subtractor, guys, full subtractor, what we can say is in full subtractor we say like let's say in full subtractor we say like so, subtraction is also A XOR B, same as uh, addition and subtraction we were see, and for borrow we have a trick. Let's say this is carry in, C is carry, alright, C is carry. So A bar B plus A bar C, then BC. This is that A takes in bar B, A takes C in bar, A in bar with B, A in bar with C, then B and C alone, right? Because those are corrupted, so like this: A bar B, A bar C, then BC. So A took A in bar with C the once time, and then A in bar with C second time, then B and C turned gay. So these both communicated and they both lose the bar without the bar. Like that. Next thing, guys, is sometimes we are being asked for n bit triple carry header and so on, so things. For a n bit triple carry header, for n bit triple carry header, we know that four full headers. This is half header. All right, this is full header. This is full header. This is full header. Carry like this. This is a triple carry header. This is not carry anything. This is like this. This is 4-bit, all right. So ripple carry header. Half header we know, full header we know how to construct, and so on so forth. So we time we need what? One half header plus n minus one full header. So for full header we need two half header. So it goes like one half header plus two n minus one half header. All right. So it goes like 2n minus 1 half headers are required. Alright, this is like this. And for time delays, we need n minus 1 carry delays plus 1 XOR delay. Carry unit delay and 1 XOR delay. 1 XOR delay we need, and we also know for carry loop header, for carry for carry look ahead header, we know that uh, carry generation of ith bit, all right, goes like either you generate the carry or you propagate the carry. Propagate means AI XOR BI, all right, then CI minus 1. This is the case. Either you generate, this is generate part GI, and this is propagate part PI, all right. So generation part and propagation part are these. For example, we say let's G3. What is G3 is? G3 always can say C3, carry 3. Carry 3 either a generate 3, either generate 3 or propagate 3 and generate by 2 plus, or propagate by 3, propagate by 2 and generate by 1, or propagate by 3, propagate by 2, or propagate by 1 and generate by 0, like this, right? And or propagate by 3, propagate by 2, or propagate by 1, propagate by 0 and generate C minus 1 means C in, right? Carry okay. So these are the things which we can propagate. We all know propagate pi this a XOR by I and like this. All right, we all know these things. Next is we are talking about the void pointer. So in data structures and pointers, we come across some things like pointer. So what is void pointer? Void asterisk p. This is how we define a void pointer. So void pointer we can say it is generic pointer. All right. We also say it is a generic pointer. So what generic pointer? It can take generic pointer. We can say void pointer. It can take, all right, address of any type of any type variable, int or float or double anything, but we need to typecast it, all right? So when we need to typecast it when we are using it, we need to typecast it, all right? So let's say we are assigning some value, then we need to type it. Let's say, so this is a word pointer. We can assign any value p is equal to ampersand x. Let's say x is integer type, int x, all right? So p is addressing to x here, p is addressing to here, like this. But what we are saying is when we are assigning some value for p, so if we want to assign some value at this, let's say we want to assign this value as 10, all right? So asterisk p is equal to 10. This is wrong. We want what we say int asterisk p, typecast p and then asterisk is equal to 10. This is integer type and this is how we typecasted it. All right. Next thing, guys, is that dangling pointer. In dangling pointer, what is dangling pointer? Dangling pointer, a pointer pointing to invalid address, which means address does not exist or free memory area. So let's say we can say like uh, what we can say dangling pointer what? Let's say uh, int p is equal to malloc asterisk p malloc size clock size of int 1 into size of int, like this, all right? So this is we assigned the row. Then what we say is free p. So this is not like this, not does not exist, and this is now dangling pointer. Or we can say this is memory leak. No, not a memory leak. This is dangling pointer. Okay. Now, next thing, guys, is some very important slide we will discuss here. Like, let's say storage classes in C properties. So we will discuss some storage classes here. All right. All right. So number one is specifier. Specifier. Then we have storage. Storage. Then we have what is the initial value. and what's the scope, and what is the life. All right. So let's start here. What is the format is specifier? Not the format is specifier, but the class is specifier. All right. Storage class is specifier. We have auto. We have auto, which means if we don't assign any storage class, then it is auto is specified automatically. All right. So auto is we say where it is stored with the variable defined by auto specifier is stored in stack. Stack and initial value will be we saw it garbage, not assigned anything, and scope will be within block within the block, and life would be method like end of block. We can say end of block like this. Then we have register also. Register. So where the storage is, there is registers. CPU register. What is the initial value? Garbage. Right. And scope within block only. And what is the lifespan? End of block. End of block. Life. Then we have some external storage class. External. Topic would be will given by like storage classes in C. So one is external here. External, what external do? External has storage of what we say. External data segment. Data segment, and it is initialized to 0. Global multiple files. Alright, what is the scope? Yes, globally, and multiple files, and what is the life of this is till end of the program. Alright, till end of the program, and we have some static class also. Static class. This is also data segment. Data segment, and this is also initialized to 0. Right, within block. Alright, static edge within block scope, and this is also till life is of this is till end of the program. Alright. So what is the syntax of storage classes if we define? So syntax would be like this. Storage class, then data type, then variable name. So storage class, data type, variable name. So this is storage. Let's say, like for example, we have some storage. We have some storage class like we can say external, int x like this. All right. Number of abelian groups of orders. All right. So if we are counting this number of abelian groups, so we can say different number of different abelian groups. We can say non-isomorphic. Non-isomorphic. All right. So number of abelian groups different non-isomorphic. We can say of order p to power k of order prime to power k. Let's say prime then k. Then what are the factors of k? Which is going to write factors of k like that. First to find prime factor. So factors are number of partitions of k. Yes, equal to partitions of k. All right. Partitions of k means like let's say it is three. Partitions like is 1, 1, 1, 2, 1, right? Then 3. So these are three partitions. So three are the uh, yes the partitions, different partitions. All right. So this is how we can prime to power k1, prime to power k2 like that. Prime 1, prime 2. Then partitions of k1 into partitions of k2. All right. All right. Number of different non-isomorphic abelian groups is 600. This 6 is that the hand. All right. Partitions count the partitions. And these are not so common questions, but it can be asked. All right. Tricky question we can do the formula based. All right. Then next is group of order prime square is always abelian. Yeah. So this is also a tricky. We can say question is it could be asked again that group of order of prime square is always abelian. Let's say 4 group of order of g is equal to 4. 4 is what? Prime ka square. Then it is like prime of order 4, we can say 9, we can say 49, well, 25 like these. These orders are always abelian. Alright. Alright. So next thing will be spatial locality. What is spatial locality? We also know that spatial different All right. Spatial locality is so possibility of different location but relatively close consecutive address references in near future. So consecutive address references in near future which are different to the current reference but relatively close to this. I'd say if we address 100, then we know that there is a high probability we will access 101 or 102 or 104 like this. This is spatial locality. This is also useful for we can say index bits being middle in indexing. We can say cache mapping. We use not the leftmost MSBs. And temporal locality is what temporal? Temporal is time dependent. So if we reference the 100 location, so this is a high possibility we reference it again in near future. Same same address referencing again in near future. This is temporal locality. All right. What we say is the next formula will be so number of memory cycles or memory access to fill one cache line. Number of memory cycle or memory access to fill one cache line is equal to size of cache line what size of data bus size of data bus in bytes we can say or anything. All right, so size of cache line and size of data bus. So how many cache line it is? So one line. All right. Next thing we will discuss guys is indirect mapped cache. All right. So we say indirect map cache. What we say is indirect map cache. If same index or same tag, let's say. So we have some tag bits. We have some index bits. We have page offset. Right? These are the three things indirect map. So if for a given address we hit the same index, let's say same index, let's say 0 index, okay, and same tag bits also same, then we say that the same memory block are mapped to the cache, which means we have a cache hit. We have a cache hit. This is equal to index and so on. But cache hit the current block from cache line. Same. No need to replace the current block from the cache line. But if we say we hit the same index but different cache line, different tag, so this is the hit case one. For we have same index but different cache tag, then we have to replace it. Miss, we say is miss, then replace the current hit. Okay. We have some different index and storing different index in cache. If the index is also different, not match the index, then no need to check the tag and no need to replace this. We will compare it with a different we can say index. Let's say it is 2, 0, 1, 2. Then we do this for different index. Right. So store in different index in case. Store in different index. All right. Wait a minute, guys. I will be back. How many? For 34 minutes only we have discussed. Here we go. Now, All right, guys, welcome back. Let's continue. In Master's theorem, we have the prototype of the problem. Master's theorem, T of n is T of n, let's say a T of n by 3, a function of n. Alright. So there are various cases, then very important also. Alright. In Master's theorem, we say a is greater than or equal to 1 and b is greater than 1, like this. These are the two conditions. So we say one thing is we can what the hell? Asymptotically greater, or we say is one thing. There are two terms. Asymptotic, 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 asymptotically greater, or in polynomially greater. Well, these are two things. So first few things like what is asymptotically greater. Asymptotically is like, let's say n log n is order of n log n is greater than order of n. This is also asymptotically greater. Alright. But it is not polynomially greater. So what we say here is, for polynomially greater, it should be greater in power of n. The power of n could be every small greater than 0. Okay? N to power alpha is greater to power n. If alpha, this is 1 here, only if alpha, this is greater than 1 plus like this, greater than 0. It can be any small value, but it should be in the power of n. So what we say, polynomial greater. Alright. So polynomial greater is like n log n is smaller than n to the power 1 plus 1.0001. So this is smaller, which is we can say order of n by 1.001 is greater order of n log n. Or we can say n log n is order of, this is, let's say fn, this is gn, then fn is order of gn. We can say this. Okay. This is the difference between polynomial and greater. So what we are saying here is, guys, for these are few for examples also. 1 is greater than, no, log n is greater than polynomially greater. We are asking polynomially greater. Polynomially greater. Log n is greater than 1? No, this is not the power of n. So this is wrong. Right? N is greater than 1? Yes. Here n is power 0, here n is power 1. This is correct. Polynomially greater. N to be greater than log n? Yes, this is true. For example, let's say n upon log n greater than 1. Yes, this is also true. Because we can say n is greater than log n. It is true only. Right? Next few things are like, is 2 to power n is greater than n? Yes. This is exponential case. Because 2 to power n is greater than n square, and n square is greater than n. So this is how, and 2 to power n is greater than n. Right? N to power 0.1 is greater than n to power 0.01. Yes, this is also true. And is this n log n greater than n? This is not true. This is false. Not polynomially greater, but asymptotically greater also is correct. Right? So this is how we will uh, define some cases of Master's theorem. So in case one, we say fn is greater than, this is greater what? Polynomial greater means polynomially greater than n to the power log base b to power a. If it is greater, then p of n is equal to f of n. Polynomially greater. Alright? Theta of n, alright? Associated. In case 2, if fn is less than, polynomially less than log b power a, then t of n is equal to theta of n power log ba. But in case 3, if fn is polynomially is equal to n to power log ba, then it goes like n to power log ba log n, like this, into log n. These are the 3 cases of Master's theorem. This is very simple. We find asymptotic complexities only, right? So next thing, guys, is some formulas here. The formulas are like 1. If fn is equal to all right, and there is some modification in case 3. If fn is equal to theta of n to power log ba log to power kn, k is greater than is equal to 0. If we put 0 log ba, then it goes like n to power log ba log k plus 1 n. This is the formula, the modification of it. All right. So next thing we will discuss, guys, is if 427 is active, if fn is theta of n power log ba minus epsilon, which means this is polynomially smaller than that, then right? Polynomially smaller than n, then it is goes like this is greater here. So theta of t of n is equal to theta of n log ba. This is the case 1. It's similar to the that case. If fn is equal to like this, n log ba plus epsilon is greater than 0 only. And now it is greater than, then t of n is theta of fn only. In the case of third, if fn is equal to theta of n log ba, we can say log kn. k is greater than equal to 0, then what? It goes like t of n is equal to theta of n log into power log va into log k plus 1 n. Like these are the three cases, guys. Now, what we saying, extended master theorems also. We have some extended cases. So let's see what are the extended master theorem cases. So this is extended. This is green color. Should we choose a green color? Can we choose green? Add green colors. All right. So we are choosing the green here. Not the green. 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 Black. We already added the green here. Extended. This is the green. All right. Is there a difference here? There is a difference. All right. So what we were doing, guys, that we were saying that if fn is equal to theta here, so this is a case of 2.1. 2.1 case 3.1 we can say 3.1. The extended is 3.2. If fn is equal to theta of n to power log ba upon log n log n, then t of n is equal to then t of n is n to power log ba log n, like these. And if in the 3.2.1 we can say if fn is theta of n to power log ba upon log n to power p, and p is greater than equal to 2 here, right? Then it does not work here. N to power t of n is and theta of n to power log ba. These are the cases for extended. So there are few cases where Master's theorems will not work. Let's say uh, a is not constant. A is not t of n is equal to, let's say, a t of n by b and plus fn. Let's say a is equal to root n. So this is not the case because it is not a constant. So we can say b barabar log n, then this is also not constant. This is not the case. This is not Master theorem how will work. And a is equal to 1 by 2. This is not. This is also not 1. Not greater than equal to 1, because a is greater than equal to 1, b is greater than 1 only. Greater than 1. B is b by 4. B should be 3 by greater than 1 only. Right? And next is let's say t of n barabar 3t n by 2. This is minus n, so this negative sign is not valid. Right? And we can say fn is equal to n square sin n. So this is not one to violates trigonometry function, not work violates we can say regularity condition. And we say where Master's theorems not work is t of n is equal to t of n by 2 plus 2t n by 4 plus n. So a and b are not fixed here, so don't work here. All right. So this is how Master's theorems not work. Some we can say important modifications for So the master's theorem also we have some modifications also. But wait a minute, guys.
लेकिन जब 46 की है, जबकि 41 की है फंक्शन की, तब से 4 समय तय करके 7 समय और स्पिनर में फंक्शन का अच्छा बेहतर तय करे तो अच्छा देते हैं, बट पॉइंट इज कि अगर फंक्शन को तय करे तो जरा भी बनाना है तो मुझे अगर से फंक्शन स्पिनर कर रहे हैं पर मुझे सब तय लगता है कि फंक्शन की निस्बत तय करे दूसरे से ज्यादा बेहतर खेल सकते हैं। उन्होंने छोटी इनिंग खेली के लिए न्यूजीलैंड देखा मगर एक टच में लगे एक बहुत अच्छा कैच पकड़ा लिया वो आउट हुए और अच्छे फ्लो में नजर आए और हालांकि कोई मैच तय करने के ऊपर है। अब बात करते हैं कुछ दिन शाह पे। मुझे नहीं लगता कि कोर्स है बट मुझे लगता है कि वो जरूरत है। एक चीज समझने वाली है कुछ दिन शाह इसलिए नहीं आए कि वो टीम के लिए बहुत के एक अच्छे क्रिकेटर है इसलिए कहेंगे कि आपके पास साइमन नहीं है। अगर आपके पास साइमन होता या कोई और क्रिकेटर होता जो बॉलिंग ऑप्शन भी होता तो शायद कुछ दिन शाह को टीम में ना लिया जाता। ये मेरी साथी राय है और उनको इसलिए दिया गया कि वो बॉलिंग भी कर लेते हैं और अच्छी बॉलिंग करते हैं। पहले मैच में उन्हें बॉलिंग की है विकेट टीम भी और अपने कुछ समझिए हमारे यहाँ कल्चर ऐसा कि किसी क्रिकेटर के ऊपर इतना दबाव डालते हैं कि बात में लगता है कि यार ये बिल्कुल ही है हमें ऐसा लगता है। यही मुझे लगता है कि कुछ दिन शाह है हमारी किसी मैच में आपको अच्छा भी करके दे सकते हैं। उनके कुछ दिन शाह हुआ है जो आउट ऑफ सिलेबस जरूर आए बट मुझे लगता है कि वो टीम की जरूरत थी क्योंकि आपके पास छठे बॉल के ऑप्शन नहीं आपके पास सिर्फ कतार था और साथ में एक ऑप्शन है आपके पास या कुछ दिन शाह एक ऑप्शन एक ऑप्शन क्या कुछ दिन शाह
All right, guys. Hello. So welcome back here. So there is a type of question we can be asked in the GATE or any other competitive exam. This is that T of n is equal to T of, let's say, square root of n plus square root of n. Let's see. This is the example here. So how to solve these type of questions? So we to solve this by Master's theorem, we need to change the variable. Change the variable, guys. ठीक है? So let's say that n is equal to 2 to the power n. We can say, so what we can say here is t of 2 to the power n is equal to t of 2 power n by 2 plus 2 power n by 2. Let's say. We don't want this, so we can also show that t of n only. Alright. So because we are changing the variable, so variable should be changed entirely. So t of n by 2 is here. Now we are redefining the this. We can say we are redefining the function only. So what we will do is this is 2 power n. Alright. We where we see 2 power m, we take the log. Log of 2 power m is 9. Alright. What we will say, this is n here. Alright. We will get n. So after this, what we will do this, we redefine the t as s of n, because we took the log 2 power m gives the m here, s of n. Alright. Plus, not the plus, is equal to s of, we can say m power 1 by 2, because 2 power 2 gives us what? 2 power m gives us, or we can say, let's say, let we can say like 2 power m, we took the log, alright? So it goes like to power log we can say we get m by 2 here, right? We took the log of base 2, we get to have m by 2, so it is like s of m by 2, right? This is not in the function, so we this is a variable only, so we left this behind, okay? Function, this is fn, this is our fn. So now compare asymptotically here. So let this is a equal to 1 here and b is equal to 2. So what we n to power log b to power a is, compare this with fn. Right? What is n b power a? N to power log 2 1. This is 0 only. This comes out to be 1. Fn is 2 power m by 2. Right? So this is asymptotically greater. So we can say S of m is equal to 2 power m by 2. Right? Theta of 2 power m by 2 all clearly. So now we know that S of m is what? T of 2 to power m. We also know theta 2 power m by 1 by 2 here. We can do this, and it goes like 2 power m is n here. Theta of square root of n. T of 2 to power m is what? T of 2 power m is n only. So we can say theta of square root of n. This is how we solve these questions. Alright. Next thing guys is, let's say question here is T of n is going to T of n by 161, let's say to power 161 dot 10. So how to solve these questions? So first we take the log. Log of t to power n is equal to 161 here. Log t n 161 plus log n. Now we define log t n as g of n. Let's say g of n is 161 log g of n by 161 like this plus log n. We can solve this like that only. And so when the answer comes g of n something theta of n, let's say, then t of n will be like theta of g, theta of 2 to power theta of n, because we took the log. Second variation is like guys this, t of n is equal to the square root of n, t of square root of n plus 100 n. Let's see. So what we will do here is guys, we took this into the denominator. So we divide by square root of t of n is t of n upon square root of n is equal to t of square root of n upon, no, we divide by n only. We divide it by n. So what we will do, n divided by n. So it will come square root of n plus 100 only. Like this. So what we will do? So we redefine this g of n is g of square root of n plus 100. So this is how we and n is equal to 2 to the power n. We can redefine this for like previous questions. So uh, one important thing here is if options are not in the asymptotic notations. If the question, then don't use master's theorem. Use back substitution for exact value. So if we want exact value out of the equation, then use back substitution. If we want options are in asymptotic notations, then all right, it's all right. But if it is fixed values, then use back substitution, not the we can say master's theorem. Don't use master's theorem. All right. So next thing here, guys, is tautology. So we already know tautology is when a given equation, or we can say given predicate function, or we can say first order logic is called tautology when all the functions are one. We can say all the values of all the possibilities always gives one. So which gives us a tautology contains 2 to power n min-terms and 0 max terms because it always gives one. Always gives one. Or we can say true. What is a contradiction? In case of contradiction, 0 min terms here and 1 max term. No, 2 power n max terms. 2 power n max terms because it always gives false. Always gives false. We can say 0. So what is the contingency? Contingency is not neither tautology nor contradiction. This that is contradiction. So for n variables, for n variables, we have 2 to power n functions. Okay. Out of which out of which we have one tautology and one contradiction. Okay. Then number of contingency will be 2 to power n minus 2. So what is the probability of contingency for a given function to be contingency? What is the probability? So while for a given function, probability of contingency was like 1 minus 2 upon 2 power n, or we can say 2 power n minus 2 upon 2 power n. This is the probability contingency. And one other thing, guys, contingency is like contingency contain one or one to 2 to power n minus 1 min term or max term, right? It can contain 2 power n minus 1 min terms, or we can say n 1 max term. It can contain one, or we can say any in the range, any number of main term and any number of x terms. Okay, in this range. The next thing is PCNF, which is principal conjunctive normal form, or we can say PDNF. PDNF is principal disjunctive normal form of any function is always unique. Is always unique, but we uh, uh, we can say conjugate normal form DNF. Disjunctive normal form may or not be unique, but PCNF and PDNF always unique. PCNF is product of sum. PCNF is PDNF disjunctive. Conjunctive is this. PCNF is this, and we can say into, we can say dot. PDNF is, or we can say plus, right, like this. Sum of product. SOP, sum of product. The principle is disjunctive. Principle is disjunctive. Principle main thing is this. So I think this live stream has gone 1 hour limit. We should end this here. Thank you so much, guys, for joining us. And we will meet you in the next one. Oh, in the next one, we can discuss what? We will continue from here only. Thank you so much.